Hello everyone and welcome. Thank you for joining me today on the stream around building a to-do list command line program in Rust. The goal of this stream is going to be to create a command line program. This program is going to allow you just to do a few different things, add tasks, list tasks, and mark them as done. So along the way, I'm really going to focus on integrating various third-party crates, which you do when you're building Rust programs. So getting more familiar with those, how to look for the documentation and get more familiar with the functionality that these crates offer. We're also going to do some command line argument parsing and a little bit of error handling. I would say that this stream is for those who do have a common kind of understanding of Rust concepts. So maybe you have written a little bit of Rust before, because I'm not really going to kind of get into the details of a lot of, the functionality of the language. So it's at least recommended that you have some understandings of concepts like variables, data types, functions, for example. You know what a crate is, but we can talk about that too. If you don't have that, it's okay. You can definitely be here and follow along, and I'm happy that you're here. So what we are going to begin doing in just a moment is building a program. First, I'll just go ahead and introduce myself. I'm Megan Lewis. I am a technical program manager on the Microsoft Reactor team. So I spend the majority of my time really kind of learning about new things and then going and doing streams like this. So really all about kind of creating content and different learning experiences. And it's great just to be here and connect with you all. So thank you again for joining me. Hello, everyone in the chat. I am watching the chat over here to my right-hand side. So if there is anything that you want to say hello, any comments, any questions, please drop them in the chat. So that's kind of all that I have to get started with. I'll go ahead and hop over to my browser. So what I am going to be going through primarily today is this Microsoft Learn module. And I will post the link there in the chat. You can find that at aka.ms/command-line-prog/web. You could also see the URL up in my browser bar there if you want to look for it that way. So this module is part of a complete learning path on Take Your First Steps with Rust. So this is the last module of the learning path. So I don't know if any of you have had the chance to go through the learning path. I think it is great at kind of building your knowledge progressively about Rust, and this final module is kind of putting all of that to use in this program. So we are going to be going through this. I'm not going to be showing the module a ton. I would recommend that everyone kind of open it and go there now so that you start to look through it, because I am going to be taking some code from it. You'll notice that it says it takes 48 minutes to complete, which I'd say that's about accurate, but we won't go through all 12 units today. We'll probably make it through about the first 8, because I want to have time to kind of stop and talk through the code. And, as you're writing this program yourself too, you should be familiar with what the code is doing. So sometimes it's going to take a little bit more than 48 minutes if you don't just want to zoom through it and really want to kind of understand what's happening in this command line program. But that is what we are going to be doing. If I hop over to the introduction unit, this is where you really kind of get the full summary of what it is that we're going to be building. So I think developing a command line program with Rust is a really great type of program to build with Rust. That's something that I think Rust is really great for. Being able to build different kind of command line tools is really popular. There's all kinds of helpful tools out there that you can find already to kind of use on your own. You can use them to contribute to and kind of build your understanding that way. But yeah, this is a definitely great place to start and really helps to grow your understanding of Rust. So there are some prereqs here. I'm going to go ahead and skip through that and really just talking about outlining the application. And from here, I'm going to jump over to my terminal and just kind of talk through this. But the program is going to do these 3 simple actions. So it's going to add tasks to a to-do list, mark task as completed, and print out the current task in the task list. So those 3 simple things. We're really going to focus on just 3 files actually today too. We're going to have kind of a file that's going to collect our command line arguments, or module rather, a module that will handle the task management, so being able to create tasks, mark them as complete, and list them. And then we're going to have kind of our main program where we put that all together. So let's go ahead and get started. So I'm going to hop over to my terminal now, and please follow along with me. All you need is VS Code, Rust, and I think that's about it if I'm not mistaken. So I'm going to start by creating this cargo application. So let's go ahead and hop over to the terminal. And what I'm going to do is focus on this Rust directory. So I just keep all of my projects. I try to keep all of my projects together the best I can. So at least in this projects folder, but I even like to group all of my Rust projects together. So this is just a collection of them. But let's go ahead and paste that command here, cargo new rusty journal. And then I will change directories to that rusty journal package that was just created. And then I just want to open this up in VS Code. So I do already have VS Code up in the background. So let's just go and search for this. So file, open, my projects, look for my Rust projects and open that up here. Okay, and then to get started with, I do have this main.rs program that you're just going to get by default when you create a new cargo project. I'm going to start by creating another new file, which is going to be for our command line arguments. I'm going to call this cli.rs. And what this is going to do is really it's going to kind of capture all of our arguments. So the arguments for our program are going to be things like adding, completing a task, and listing a task. So I'll hop back over to my browser for now, just so you can kind of see what I'm going to be doing here. And this is the process that I'm really going to be following. But we're going to start out by using this struct opt crate. So struct opt is pretty much the most common crate for collecting command line arguments. You can definitely search in your terminal. I think this search is a great feature if you want to get more familiar, or at least learn the current version of the crate that's available. That's really helpful. I would also recommend just keeping the docs page handy so that you can come and take a look at different crates and understand what they are doing and what they're for. So if I go to docs.rs, then I can just search for the name of the crate that I'm using. You might see a lot of results like this, but I know that this is the version that I want here. So what this crate is going to do is define the struct opt trait and its custom derive. So it gives you some ideas for how to actually use the struct opt crate. And what we're going to be doing is going to look something like this, is basically what we're going to set up. So definitely these examples are helpful just to know how to derive struct opt. So first, what I want to do is add struct opt as a dependency in my cargo.toml file. So I will just go ahead and copy that from there. And there's no shame in copying, because that's how you can kind of get a program, standing up pretty quickly. So that's what we're going to do today in the interest of time. All right, so at my cargo.toml file, right under the dependency section, I'm going to go ahead and add my first dependency, struct opt there, and then go back to cli.rs. So I'm going to go ahead now and add in the code that's going to be available to create our subcommands for the command line program. So let me just go ahead and add this over here, which is going to be a lot of code for now, but we're just going to go ahead and talk through it. All right, so we are using struct_opt, so we're going ahead and using that crate. We're also using this path buff. So this is from the standard library, and path buff is basically just going to allow us to read in a file. So let's go ahead and start at the top here. So I'm defining this enum action. First, what you'll notice on line 4 is we're using this derive tag. So what we have to do is derive the specific attributes that we want to use. So struct_opt is one of those, and it's basically going to allow us to use struct_opt attributes within this enum here. So add, done, and list. Those are our 3 subcommands that are going to be available for this program. So you can think of subcommands. I think a good equivalent that I try to remind myself of is like if we have a get repository. Get, you have things like add, commit. Those are really great examples of subcommands that you can have. So for this action enum, I have these 3 variants, which just create subcommands for me. This line up here, this kind of triple / is going to indicate the description for that subcommand. That is basically just going to help give me more context or give anyone using your program more context about what these different commands are allowing you to do. And then I'm also defining what is allowed along with this command. So I am going to take in a text. I'm going to take in some text, which is of type string. So done will take in a position, which is some usize. It's basically just any size. We're going to be working with pretty small sizes here, like less than 10, but it's possible that there could be, you know, lots more items in your to-do list. And then finally, this last variant here is list, and that is not going to take any arguments along with that subcommand. So then down here, what we are doing is creating the struct for our command line arguments. So the struct is saying that we are going to have an action. So it's actually going to be using the actions that we defined up here in this enum. And then we are also having this option for a journal file. So the journal file is just going to specify basically all of our to-do list items. We're going to group them in there. So that's essentially what's happening in this file. And it'll make a lot more sense when we run it in a moment. So let me go ahead now and focus on the main.rs program. So let's go ahead and open that. And so I'm just going to get rid of all of this and copy this kind of initial main program definition from the Learn module. So you'll notice that first I am using my CLI module that I just created over here. I'm also bringing in struct_opt here and just kind of being able to say I want to use CLI command line arg. So that is that struct that I created over in the CLI module. And I want to be able to collect the args. So I'm going to open up my terminal here in VS Code. I prefer that terminal because I can kind of just focus on what's happening in the program and not have to go to another screen. So I'm just going to start it with a cargo run. I would recommend doing this. It's just going to go ahead and compile the program. You see that it's going to download any crates. There's a lot of stuff to compile initially, so let's just wait for that for a moment. All right, so then once that is done, if you're following along, you should see the same thing that I do here. So this highlighted part is really what I want to focus on. So I see the name of the application, Rusty Journal 0.1.0, a command line to-do app written in Rust. There are these usage. So basically all of this is generated for us with the help of the struct_opt crate. Some of it we have defined, but some of the the usage text here, the flags are all just going to come by default with struct_opt, which is really great, and that's one of the benefits of why people use struct_opt. There's also the option. So this is what we defined in the struct, the command line arg struct over in the CLI module, where we can take in a journal file. So either with -j or -- journal -file, and then we specify some kind of name there. And then there are also those subcommands that we defined. So we defined these 3. So there's add, and then that description from the add subcommand, there's done, and there's list. So that's basically going to be the basics of our program and how we're going to be able to use the program with these different options, as well as with a subcommand. And just to refresh everyone's memory, that is directly coming from here, basically everything that you see when we run the program. So that's pretty cool, just to see immediately that, like, this is what we get by using struct_opt. I am going to modify one of the lines in main.rs. So I want to collect the args, but for now I actually just want to print them out. And then we can try to just use the program and see what we get printed out as a result. So let's go ahead and say initially I want to say cargo run. I'm going to do this -- here just to specify that this is not a argument of cargo. So this is kind of just starting out a new argument for this actual command line app. I want to specify -j, -j for my journal file, and we can call this groceries.txt. A text file is fine for now. That's probably the easiest kind of file to work with. But other types of files are allowed. We can use a JSON file as well. And let's say I want to add some kind of grocery item. So I can say we need bread. Oh, and I think something was wrong with my command. Sorry. So, and yeah, again, this is why I love Rust. Something is obviously wrong. And it tells me that it's around this bread part of the command. So I didn't even use the subcommand add. I just went ahead and tried to add bread. Silly. So, all right, now I can do that. And here's what I see. So my command line args do get returned to me as this kind of JSON object, where I see that the action is add, the text along with that action is bread, and then specifying the journal file that I'm going to use here. So that's pretty cool. We can also try to do a, now let's say list, and see what happens there. So now if I list what's in my groceries.txt file, I have seen the list action was used, and then oh, okay, so this was the file, but then I don't actually see my bread in there. Okay, so that's something that's fine. We're gonna implement that in just a moment, but I don't actually see that yet. Similarly, let's just see what happens if we say done was the other option, and for done, you're just gonna enter in a position. So the first position is going to be 1. Let's just see how that works for now. Okay, so basically we haven't implemented this yet, but we do see that the commands are working as we expect them to. So the action was done, the position was 1 for this groceries.txt file. So that's pretty much all we have for now. So let's go ahead and jump into the more juicy part of this program where we can start to implement the task module. And please let me know if there are any questions so far. Okay. Otherwise, I'm going to keep going. So what I want to do now is create a new file. This is going to be called task.rs. And so this is going to be where we manage all of our tasks: add, complete, and list. So those are going to be kind of the main functions that we focus on within this file. So let's go ahead and get to it. I'm going to go ahead and skip over to the 4th module of the fourth unit of the Learn module. So if you're following along, that's where you should be. And I hope everything is working out for y'all as you are working on this program in the background too. So what we want to start by doing in our task module is we're going to define this struct. The struct is going to be called task, and we're basically kind of just defining what is going to be a part of our task. So I'm going to just go ahead and bring this over to start with. So again, we have the struct task. We're saying that the task is going to have some string text associated with it. So like red was, the text in my last example. And then we're also going to have some timestamp that this task is created at. So that's what we're going to see in every task that we create. And you'll notice here that I have brought in this chrono crate that we're going to be using. So this is basically going to kind of create that date time timestamp for us. So we are going to have to go ahead and add that to our program. So before I do that, I will hop over to the browser. And again, I'd recommend, especially when you're kind of just getting started, you probably just want to go, I look up everything personally, especially if it's like this and, I'm following along with some program, but I'm not really completely sure what a crate might do. It's definitely helpful just to come and look it up and see what's happening with this crate, even though it might be totally clear, but you can just kind of come here, get the latest information about, okay, this is the version that I want to use. Here are some of the features. And sometimes it's a lot of information. Maybe you just want kind of like an example of how we're actually going to be using this crate, which we're doing something similar to this, is just kind of getting the date and time in UTC. But definitely I recommend kind of coming to the docs page and just familiarizing yourself there first before kind of moving on too far. So back in VS Code, and the cargo.toml file under the struct op dependency, I'll go ahead and add in this chrono crate. So we're good to go there. Back in the task file, I'm probably going to keep going and adding on to the code just to let you know. You can also always come back and kind of do a cargo run or like a cargo check to confirm that everything is still working well over here. Which it should be, so just helpful information. One other thing that I didn't call out, and that you'll see more of as I start writing more code, but I am using an extension called Rest Analyzer. So if you go over to this kind of building blocks icon on the left toolbar here, you'll see Rest Analyzer. Rest Analyzer is my favorite Rust extension, which I think provides a lot of really great support as you're writing your program. It highlights a lot of information for you, particularly like warnings and errors. So I did just go ahead and actually check and do a quick compile on the program. But if there was a problem, Rust Analyzer would tell me otherwise. So it's kind of nice to have that as well. So you're not kind of constantly wondering if everything is okay. All right, so let's save this and go ahead and keep going for now. So the next step that I'm going to do is to implement a method to be able to instantiate new tasks. So I'm going to use this to do that. And what this is basically going to do, I use this impl keyword. So I would say I want to impl a task, which is basically just saying we're going to implement some functionality for this type. We are creating a new function here that's going to return a task for us. And so basically we're having this created at date where we are using that same date time. And then our task is going to look just like this is what we'll see eventually. And this is also going to define that kind of function task new. So we're going to be able to easily just create new tasks that way. So these kind of work together. The struct and this impl task are going to allow us to easily create new tasks together. So the next thing that we're going to talk about, and this is pretty important, this whole concept around serializing and deserializing task. So for that, what we're going to introduce again is another crate. And let's go ahead and look up this crate. I think this is the one that I want. And so this is showing me a module. I am looking for the crate. Chrono. But it's going to allow us to deserialize. I'll keep kind of talking about that in the background, but basically serializing and deserializing are what's going to help us kind of persist these tasks somewhere and then be able to access them from somewhere later. And I don't really want the module. I did want the crate. So, let me keep looking for that. Crate chrono. And sometimes I start here, but if I can't find exactly what I'm looking for, then I can also just Bing it. Maybe this is what I'm looking for. I have looked it up in the past. Okay, so yes, we are going to use this crate Serde, and we're also going to use a Serde JSON to basically just kind of format our tasks nicely in a JSON format. Yeah, so yes, it's going to have a couple different traits that we're going to be using. So that is going to be deserialize and serialize. And if you kind of drill down into these, like serialize, for example, you can get a lot more information about kind of the required methods and some ways to implement this serialized trait, for example. So just helpful to know that we are going to be using that. Feel free to look that up and learn a little bit more about it. So we're going to go ahead and bring these new crates into our program, into cargo.toml. So we're going to be doing something a little bit interesting here where we're going to kind of restructure our dependencies. So I have in my regular dependencies just struct.opt and chrono for now. I'm going to add Serde JSON into here, which looks like the latest version is 1.0. And then I'm going to add separate sections for my Serde dependencies and my chrono dependencies. So first, let's go ahead and start with dependencies.Serde. And I'm going to say the version that I'm using for that is 1.0. And then the features, I'm going to just be using derive for that. So that's the feature I'm going to use there. And then I'm going to create this other dependency section for chrono. So I'm going to say .chrono. So here the version is going to be 0.4, and then the features is going to be Serde. So we are using chrono with Serde basically. So what we're going to have is this task that we're going to need to serialize. And so chrono is kind of providing this date timestamp, and that's essentially what we're going to serialize the task on and be able to kind of access them from that. All right, so what we can do next is go ahead and kind of modify our task.rs file slightly to go ahead and introduce what we just added. So first I'm going to update the crates that we're going to be using. So here we're using chrono. I'm specifying now that, and in addition to just before, I think we had date time in UTC, we are using Serde to serialize. Then we're also bringing in Serde, and then this trait to serialize Serde, and then the trait serialize. So that is what changes there. And then our struct definition is also going to change. So let me go ahead and bring that over too. And I can just for a second paste it right below, just so we can see what is changing here. But in addition to the debug attribute, we're also bringing in a couple other attributes to use with this task struct. We're still having the string here, nothing's changed with that, but we are specifying that we're using Surday to serialize the date time. And that's basically what's changed there. And you'll notice as we are kind of going through this, like even the module kind of builds on this program iteratively and adds in new crates and such. So just kind of understand again what's happening with each of these different changes that we're making to make sure that that makes sense to you. If something doesn't, ask. I'm kind of, walking through this again and providing explanations. You'll see explanations in the module as well. But yeah, just make sure that it all makes sense to you. I think that's really important. All right, so what I'm going to do next is focus on adding in these 3 functions. So this is kind of going to be the core of our program. There are going to be these 3 functions for add task. You'll notice that add task will take in a couple different parameters. So there's going to be the journal path. So the journal path is just going to be whatever file that we pass in to put the task in here. And then there's also going to be a task, and then it returns some kind of result here. So basically the result that we're going to be expecting is that it's either like, okay, everything is great, or not great. Generally is what we're looking for. Or you'll also notice that there are these empty parentheses here, which is just an empty tuple, which is basically just going to say that there is no type currently associated with that, but like we're able to accept any type that comes back, essentially. So you'll notice that all of these 3 functions are returning this general result. So again, really all we're looking for there is like everything is okay or not okay. So an error otherwise. The complete task is where we're going to be able to mark a task as done. This takes in a journal path and then some kind of position. So some kind of integer there basically, which again, we're just going to be working with numbers like less than 10. There's also the list task function, which just takes in the journal path, and that's it. So let's go ahead and implement these functions now. I'm going to kind of move on to the next section where we're going to focus on doing that. So let's go ahead and get to it. So I'm just going to go ahead and start after this impl task block here. And on line 20, I'm going to paste in this initial function to add in a task. And I copied that exactly. So let me do a little bit of reformatting here. And so I'm going to go ahead and add these use statements up to the top. So we're going to be using something called open options from the standard FS library. And then we're also using standard IO, so input output operations. And these are the different options that we're going to be using. So let me go ahead and talk about those as we look through the add function. Okay, so and I'm going to save this just because. So what we're going to start by doing is by using open options. So open options is just allowing us to specify what we are going to do with that file. So what we're going to be able to do is read, write, and create, and open the journal path. So that's basically all the functionality that is available to open options that we're going to be allowing here in the add task function. And we're essentially going to kind of do all of that. Generally, like, especially when we're just getting started, we want to create a new file. We want to be able to read to it. If it's a file that exists, first we want to be able to read what's currently there and maybe write over that. So we're going to be doing a combination of all of this with the open options. You'll also notice that there is this question mark here. So this question mark is basically just going to allow us to propagate errors easily. So I think this is a really cool part of the Rust error handling functionality that's available. So we don't have to write a whole lot of code to basically unwrap this possible error that might happen. So we're just going to say, like, if it's okay, it's okay. Otherwise, if it might fail, just return an error. So that's all that question mark is saying, essentially. And then the next part, let's kind of focus on this here. Here we are using this from reader function, and we're basically just going to read the file. And we want to read that into a vector of task. And then what we're saying is we want to basically have these are the possibilities that we're going to have when we read this file. It's either going to be okay, and we're going to be able to add these new tasks. It's either going to result in an error. So if the error, let's say, is end of file, like we don't have anything in that file to read, or there could just be some other type of error that could happen. And then we're using that same kind of question mark notation here just to say, like, hey, we're going to catch any possible errors that come up, and then we can have those returned back to us. So that's essentially what's happening in here, but we're hoping that everything will be okay from reading this file from cert.json. It's going to return it back as a vector of task into in a JSON format. So then the next bits, and we can kind of talk about these bits together. So this is using something called seek. So that's kind of an input operation that we have. So this seek trait is going to allow us to kind of rewind the file. So basically the way that we're reading this file, we have moved the cursor to the end of the file to read it. So we just want to rewind the file or bring the cursor back to the beginning before we write over all the contents again. Because that's basically what we're doing, especially if there's already a task in the file. We're kind of just like rewriting over the whole file after we've read it and just adding in additional task at the end. And then finally, what we're doing is writing the modified task list back into the file. So we're just going to go ahead and push that task. And we're using cert.json to write to that task vector. And then ideally we return okay after that. And that indicates that everything is okay. So next, let's focus on writing this function to complete the task. So let me just go ahead and copy that over here. I'm going to add that right after the add task function. And this is, again, kind of just the first iteration of that. So I'm going to move this up. And from this standard IO set of libraries that we're using, I think these are the only new ones, these error and error kind options that we're going to be using additionally. So just to know, if you're following along, you don't need to have all of that duplicated, and your program would have a compiler error. If you try to have that as a separate line, it would tell you that there's too many of the same modules that you're trying to use. All right, so let's go back to this. So for this complete task function, we're going to start pretty similarly here, where we have the open options, and we're going to be able to read, write, and open the journal path. Notice that there's not any option here for creating like there was up above. We're not going to have that be a possibility here. So we're going to open the file. We are going to consume the file's contents as a vector of task, doing any error catching here. If there are some errors with reading the file, the contents in the file, anything like that. And then what's different here is we're going to go ahead and remove the task. So we say if task position is equal to 0, or task position is greater than 0. We want to return some kind of error. So invalid task ID is what we're going to have here. So if task position is greater than task.length, I think I said that incorrectly. And then essentially what we are doing is just finding the right position, removing that task position here. And then we kind of do the same thing that we just saw in the add function above. I think you'll notice that those last few lines are exactly the same, where we rewind the file after reading from it and then write back the modified list into the file. So it's a little bit different here where we're adding a new task here, and we're removing another task there. So I guess that's the difference here, but we are rewinding and truncating the file and writing the modified task list back into the file. So that's essentially what's happening there. So we are gonna go ahead and refactor the task collection. We're just gonna use this general kind of collect task function for handling what we're doing with the file parsing and kind of making sure we're in the right position using seek to rewind the file and put our cursor at the accurate location, basically. So I'm going to do a little bit of modification here. I'm going to just scroll up to above the add task function and go ahead and paste this collect task function here. So and this is pretty much what we have seen before. So let's go ahead and see how that changes the function definition for, let's start with add task. So I'm going to scroll down here. And so what that has removed is so we start from the let mute task. So that's going to take out all of this essentially, where we're going to be saying, now first you just collect task, and it looks like that collect task is just taking the file to collect tasks from and pass them back into this vector of task. All right, and then what are we doing after that? This should be a part of that function as well, file.seek, okay, task. So then what we're going to do is still write the modified task back into the file and end with okay. So that should be all that we need there, but you'll notice that it cleans up that file quite a bit. Similarly here, we can get rid of this. So we're just going to be saying collect task in file, and then we can see what else changes there. So this task position stuff is still necessary. We do not need this anymore still. And then the last two lines are okay to go too. So let me take a break now and just see if there are any questions. This is probably a good time just to take another look through both of these function definitions, since we just added a bunch of code here, and just to see if that's all checking out. Will toWriter automatically truncate the file in case it's gotten shorter? Okay, I think it looks like that question was answered, but will toWriter automatically truncate the file in case it's gotten short? Okay, yes. So sorry, I was just having to look for where that was. So yeah, we are writing the modified task list back into the file. I don't know, I think maybe that makes more sense in the complete task. So essentially what's happening here, and I guess what the difference is, like we're basically rewriting the contents of the file each time. So it's, you know, when we're adding a task, it's easily able to say like, okay, let's just go ahead and add on to the position. If we remove a task, let's say that there are 2 tasks and we remove the first one, it can kind of just like rewrite that order for us. If there's more than that, removes one in the middle, it can kind of just rewrite that order for us too. And that's what seek is helping to do. Essentially, it's just to make sure that we're kind of adding things at the right position in the file. Any declaration errors that we need to be aware of? I am not sure. I'm not sure exactly what you mean by that. I think we are doing, well, first, like something that, yeah, you might want to be doing is just checking and compiling and making sure that everything is okay here as you're going on, to make sure that there are no specific errors coming up, just with the program, and that it compiles smoothly. We are doing our best here to try to catch errors. So you'll notice that we're doing that at places where things can go wrong. So specifically when we're reading through the file, I think that's when we're doing a lot of kind of this basic error catching with being able to check this, or using this kind of propagation, catching any errors that might arise. But typically, like any time that we're reading a file is when things can possibly go wrong. That's also why we're just kind of returning a result generally back from each of these tasks, just to be able to propagate those errors if they happen as well. All right, let's go on to the last function that is just going to print a task. But before I do that, I think that there's just one more question. When using OK, don't you need to treat a possible error as well? You don't need to. I think that this will return OK if OK, and return the error if not OK, essentially, is what's happening, and we are catching the result here. So there's not anything else that we need to do from that. And we can even try when we're running the program, like, and this is, I mean, what I'm always thinking about is trying to think of those errors that we can try to surface. So let's say when we're running the program, like you want to complete a task that's not there and kind of like see what happens there. You want to pass in, some ID that's not there. Like, you can think of the ways that you can try to break that and just see what happens to you if you're not sure if you're catching all the errors. All right, so for this last function, we're just going to go ahead and print all of the tasks that are in the journal file. So I'm going to go ahead and add this right after the complete task function. This function, I think, is pretty straightforward now. I think this is maybe the easier of the previous two functions that we've looked at, where we take in the journal path, we return some kind of result, whether that's okay or not okay. We are using open options to just read and open the journal path. We're not doing any writing or grading. We are collecting all of the tasks in the file there, and we are enumerating and displaying all the tasks if there are any. So if it's empty, we can just go ahead and print this. Otherwise, we can use this for loop to essentially just iterate through all the tasks in the list and go ahead and print them out. So that's all that we really have going on in that file. Again, I think it's a little bit easier than some of the others. The last thing that we're going to do before kind of hopping back over to the main file and testing out our program is we're going to implement this display function. So what this display is used for is, and you can see what I'm looking at here. If you're following along, this is where you should be. So it's saying, note that this code won't compile because the task struct doesn't yet implement the display trait. So we need to go ahead and implement the display trait for the task struct. And essentially what this is doing is making it kind of formatted nicely. So we are being able to format the timestamp with this created at time zone local and format it kind of like this. So format in hours and minutes. And then we are going to write that nicely, essentially. And this definition might explain it a little bit more clearly than I did. So under here, I'm going to go ahead and paste this in here. This use can go ahead and just be at the top. And sorry, I'm back in VS Code now. So I just went ahead and added in this display function so we can display the task, and added that at the end. So that's essentially completing this task.rs module. You'll notice that kind of the big, the main functionality for our command line program is in this task module. I see someone was asking for the document link, and yeah, I should go ahead and post that in there again, just in case folks have joined later, but I am at aka.ms/command-line-prog-web. So please keep that handy. It would be really helpful when following along. And then the last thing that I want to show here is to go back and update the main module so that we can run the program with our new task module included in that. So what we had initially was just this main function that went ahead and printed out the command line arguments that we were passing in. It wasn't really doing anything more than that. So first, let's go ahead and modify just the modules that we're including. So after module CLI, we're also going to include the task module there. And then we also need to use, we're going to add this. We want to be able to use CLI. We want to use that action struct as well as that command line arg struct. And we want to be able to use here the task struct as well. So we can kind of just pass that in this way. And then in the main function body, this is what we'll change here. So we're going to get the command line arguments, the action in the journal file. And then we want to unpack the journal file. So here we're using another possible way to catch errors. So we can say expect if, you know, some kind of exception comes up where we, you know, failed to find the journal file for whatever reason. It doesn't exist. It's not a valid format, something like that. Then we can perform the action. So we're going to use this match expression here. And we are matching the action based on the command line argument. So if it's add, we're going to go ahead and call the add task function from the task module using these parameters. Similarly with the list and the done arms of this match expression, we can evaluate if they match to the command line. We'll go ahead and execute this function call here. And then if that fails, we're also doing some kind of catching here. So we can say failed to perform action or something. So that is basically our program that we have for now. This is kind of the initial, we can call this V1 of the program. So let's just go ahead and do a general cargo run to begin with, and we can see how things are looking there. And it might take a little bit to compile because I have not done iterative compiling at this point. Okay, and there are some errors, but it is okay. So, oh yeah, so this is probably helpful. And yeah, let's go see what's going on. And if you all are following along, maybe you're seeing the same problems that I am, and we can figure out what's going on here. So let's go back over to task.rs, and I'm going to kind of minimize this so it's not taking up the whole screen. So this first is at line 23, cannot find type file in this. Mute file. Help. Consider importing one of these. Is it possible that I forgot to import something? I think so. Am I not importing this file here? That would be helpful. So somewhere I might have missed that. Somehow, I think that's the big one there. I'm pretty sure is that I was not importing from the standard library this file type, which is actually going to allow us to work with the file. This next error, and I'm going to try to look through a couple of these and then run them over, because I think there were a number of problems. Cannot find type path buff in this scope. And that's something that I think I just didn't add. So again, the compiler is super helpful because it's like, you probably forgot to do this, and I did. So I just forgot some import statements. And I know that that's the one that I want. I am using pathbuff when I'm adding the task, just to kind of be able to read that file again, read from the pathbuff. So I do need that. Cannot find, I don't know how I forgot all these import statements, but it's okay, we're fixing it. So cannot find type task in this scope. Similarly named struct task defined here. So this line error is coming from line 43. Back task. Okay, so I don't think I need this here. Is that the problem here? Let mute task. Okay, at this point, let me try to run a couple of them, or let me try to do a cargo run again to see what happens. I have added pathbuff, right? So that should be fine. Import, unused import buff reader. Maybe I can get rid of that if I'm not using that. And then I'm also going to do a little bit of cleanup here. I noticed that I'm also using this from standard FS, so I can just kind of group these together, like I'm just putting all the IO operations together. So let's say that I want to use file up there and get rid of that. Okay, that looks better. So let's just go ahead and see what happens. All right, so there's still some errors. And I'm just trying to see where they start. So, what else am I missing here? So let's go back up to, where did I compile this again? I did already get rid of buff reader, right? All right, here's where I want to start. There we go. So there are less errors. It was overwhelming at first. I was like, did I not fix any errors? Okay, so no method for named push. This is coming from line 47. So what did I do wrong there? (47) task.push task. Task.push task. That looks right to me. Did I mess something else up in file? Task.push task. So no method found and result. Wondering what else that I completely messed up. Task.push. Maybe this is why I should have run my program incrementally. So I thought that Rest Analyzer would pick up on those errors for me, but I think I'm still having some difficulties here. And where else? We're using task.push other places, right? So where is the... No question mark after collect task. So task ends up as the result. Did I mess up something with collect task? Let's go see. That looks okay to me. Or am I find the file after. Yeah, that looks okay to me, and I'm gonna go back and check and see where I went wrong too. And just see what other errors that we can fix along the way. Thanks for bearing with me, y'all. And I'm curious, is this working for other people? Have you completed this and are running your program successfully? File, task, okay. Serialize is not implemented. Oh, okay. Serialize is not implemented for standard IO error. Debug, serialize. No module name length. It almost seems like I'm forgetting to import something again. Serialize, deserialize. Error kind, result. I've been cutting and pasting as I go, so I have an entirely different set of errors. Okay. How is it working for other folks? I'm curious. And sometimes this happens and you just have to work through it. I think the first set of errors were a little bit more straightforward. Like usual, I feel like I'm missing something obvious. Task set remove, task position -1, complete task. Okay, and then how do you look different? All right, I'm gonna try to run this one more time. All right. So something about that copy and paste fixed it for me. I must have had some kind of weird typos somewhere. And if you're getting weird typos, look through it, make sure that you're doing everything correctly, make sure that you build your understanding. But that somehow fixed it. So I must have just had some weird errors going on. But anyway, I did want to go ahead and show now that you do have a running program, and hopefully y'all do. Take some time to fix up your errors. Let me know how that's going. We can see what's different about our program now. So if I want to go ahead and run it, like I was doing initially, I might have this groceries.txt file, and I could add something to it like bread. Then let's go ahead and see now if we list from our groceries.txt file. I should have that file created here in my project directory. You'll notice that it is in this kind of JSON format where I have the text that is bread and the created at timestamp. Cool. And then I can go ahead and list directly from here. So if I list in my terminal, I can close this to make this easier to read. I can see that I have bread here. I can also then mark things as done. So let's see if I say, for example, done 2. this should throw an error. So like I was mentioning before, try to catch and verify that your errors are throwing as expected. So the program does just panic here, and it says invalid task ID, which we should have defined in the complete task function over in here. That was one of the error catching the error catching that we were looking for. So it's saying if basically this task position doesn't exist, for example, so we can look at that there. And then confirm that we can actually mark things as complete there. So now if we were to list the groceries text file again, we can see task list is empty. So just feel free to play around with that program a little bit more, get familiar with how to use it. And I think, you know, the more important thing is just building your understanding of command line programs in Rust, since that is something that is a really type of program that you can build in Rust, and you can build some really, really helpful command line utilities. So it's definitely something fun to play around with. I appreciate that it is kind of command line. I think you don't have to worry about building some kind of UI over it. You're really kind of just building some program that you can test out immediately. To close, I'll just go ahead and pop back over to my browser. And I wanted to call out that we got through about section 8, unit 8 of this Learn module, and that there are a few more modules after this. So this one is about using a default journal file to store tasks. There's also this section that I think will be really helpful about displaying more friendly error messages than just kind of panicking and throwing out a message like this. So the next few units are really just about cleaning up the program and making it a little bit more user-friendly. So I definitely recommend checking that out as well. And thank you all again for joining me today. I hope that this was useful and that you now have some command line program that you can kind of use and play around with and learn from a little bit more. So that is it for me. I want to just take a moment to close and kind of share my contact information here. If you want to reach out, talk about anything Rust related, you can reach me on Twitter, LinkedIn, on email. I'm always happy to talk more about this stuff. Of course, you can see I'm always still building my learning as well. And then lastly, I would just encourage you all to go ahead and check out the survey at aka.ms/reactor/survey, and the event code there is 12963. And that is all that I have. Probably just one more time, I'll go ahead and throw in the Learn module link at aka.ms/command-line-prog-web. Please go and check out the rest of that learning path. I'm always eager to kind of hear feedback on that learning path as well. So thank you again. I hope that you all take care and have a great day.